Hey everyone, so the question right now we're taking up is evaluate reverse Polish notation. The best way to solve this is by using a stack. Let's see why. Because in reverse Polish notation or postfix notation, what happens is our operators are placed after the operands. So in stack, what happens is if we use a stack data structure, we can process the operators in the order of how they are seen and can apply we can process the operands in the order they are present, and we can apply the operators to the most recently seen values. So that's why we can go ahead with stack. And the core logic here is that we'll have four steps. Firstly, we'll iterate through every character in our expression. So we'll iterate through the tokens array. And then what we are going to do, if we encounter an operand or a number, we are going to just push it onto the stack. So iterate, the first step is iterate through tokens array. Then if we encounter a character at ith element, we if a number is there, we push the number to the stack. If let's say if we encounter an operand, what we do, we pop out two numbers from the stack and we apply the what do we apply the operation that we are supposed to do. So yeah, and in the end what will happen is we'll be left with one element in our stack, and that will be the result. Okay, so let's get started. So in here we're using a stack of integer. Let's name it stack is equal to new stack. Now what we do, we iterate through. So for string token in tokens array, now we switch. We can also say, like, if let's use switch token case. There can be case of, we can have four operators, which is plus. Let's use fall through property. Can be minus. Can be multiplication. And it can be division. Pop out two numbers, perform the operation, and push was this thing. I forgot. And push back. Push the result. So then we'll have division here. So if, let's use double quotes. Yeah. So if this is the case, what we're going to do is pop out two numbers from the stack. So my first number will be st.pop. Sorry, my second number will be st.pop, and my first number will be st.pop again. Fine. Now, these will be numbers because we are storing integer. Now we perform I mean, if I write this way, what's going to happen is I'll have to do the checking again. So instead of this, we can do one thing. if, like, let's say instead of this, we can do one thing, which is, so now we have to perform the operation, right? So now what we do is, now since we've popped, this was the catch here, because our first number or my first operator will be the second element popped. So this is the catch here. We always have to do A operation B. Now we're going to check if my token dot equals a plus. Then what we do st dot push A plus B. Else if our token equals minus, we are going to do st dot push A minus B. Else if my token is equal to multiplication, then we do st dot push A into B. So else we do A by B. So always remember, our operation would be A by B. Okay, now we break. And then we have a default case in which what do we have to do? We have to just push the number into the stack. So we'll do st dot push integer dot percent token. And yeah, we iterate through those tokens one by one. And in the end, we are just returning st dot pop, since we'll be left with one element at the end. Yeah, there was an E missing. So the time and space complexity is, see, we're always processing each token once. And at max, we are having this stack of integer which can store n values. So our time and space complexity is linear, which is big of n. So yeah, thanks for watching. Bye.